Okay, lecture 34. Know the definition of oxidation number. We're about to use them here. So determine the oxidation numbers for all the elements in each of the following. Well, first one is just helium. And what you normally do is you put the oxidation number above the element. So helium, if you look at our first rule, elements, the oxidation number of an atom in an element is 0. So that's 0, that's easy enough. So anytime you just see like tungsten on its own, it's not an ion, nothing else, it's just 0. Technetium, if you just see the element on its own. But if you have the element naturally occurs as a diatomic molecule, like oxygen here, there's no charge on it, there's nothing else attached to it, then each of the oxygens is 0. You just put a 0 above the oxygen, even though there's a subscript here, they both are 0. I'm putting some extreme one. Now phosphorus phosphorus forms a tetrahedral structure, like a pyramid, and that's how it naturally exists. So when you see P4, again, no charge, then all the phosphorus must be 0. S8, a more extreme example. Sulfur likes to form into 8-membered rings. It looks like a stop sign, or like a buckled up stop sign, because they don't sit planar, but the atoms kind of buckle, but they're all in a octahedron pattern, or a octahedral pattern, or octagon pattern, I should say. So we have sulfur S8, and each of those sulfurs is 0. That's our first rule about elements. Now, when we have an element that has been changed into an ion, the oxidation number is equal to the charge. So when you have monatomic ions, the atomic number of an atom in a monatomic ion equals the charge on the ion. Sodium is +1, so this is +1. That's easy enough. Actually, the first rules are pretty easy. Copper +2, so that must be +2. Notice that when we deal with ionic charges, we usually put the number first, followed by the sign. But when we're dealing with oxidation numbers, it's just a number, so we write it as we would. Well, usually put the plus in front. You don't have to, but the negative has to be in there. So it's a plus. Carbon 2+ is the oxidation numbers, +2. Nitrogen, or the nitride ion, is -3, or 3-, so that's a -3 for the oxidation number. Any monatomic ion element that forms an ion, or a monatomic ion, is whatever the charge is, that's the oxidation number. So 2-, -2, piece of cake. Now, if we have a compound, then we have to use the oxidation numbers of what we know from the rules and figure out the ones that we don't. The third rule is that oxygen, when it's part of a compound, it's always -2. There's one exception, and we'll see it later. But anytime oxygen is part of a compound, it's -2. And you say, well, what about that oxygen we saw earlier? Remember, this is not part of a compound. It's an element. It's a molecule, diatomic molecule, but it's still elemental because there's only oxygen, so that's 0. But when oxygen is part of a compound, no, it's -2. Now, this is actually rule 6, but what we do is when we're trying to determine the oxidation numbers, we have all of the oxidation numbers together have to add up to the charge on the species. This is neutral, so we don't know what copper is. We can make that X, and there's 2 of them, so 2 times X minus 2 must be equal to 0. And a lot of this you can do in your head. The vast majority of them I can do in my head because I do this all the time, but you'll be able to do it very quickly. There's only a few cases where you might want to stop and just verify it with a quick equation or quick plug into the calculator, but most of them you can do in your head. But you can see that 2x is equal to 2, so x must be equal to 1 or +1. So copper, and since you already know how to name this, or you should, you can see that this is copper 1 oxide. Okay, now we have a polyatomic ion. Sulfur, there's no rule for sulfur, and we don't have a rule because sulfur can be more than one oxidation state. Oxygen is -2. Again, there's an exception, but it's very, very rare, and you will definitely know it when you see it, and that's why we're going to cover it later on. So we have oxygen is -2. Sulfur we don't know, but we know that X, there's one sulfur, plus 4 times -2, 4 because there's a 4 here. There's 4 oxygens, they're each -2, and that has to equal the charge of the species. In this case, it's not 0, it's -2 because it's a polyatomic ion. So we have x minus 8 is equal to 2, and so x is, we find, equal to +6. So sulfur in this case is +6. Let's see, halogens. The oxidation number of fluorine is always -1, and I don't know if I have that, but fluorine, the oxidation number for fluorine is always -1. So that's a nice one to have. Oxygen is -2, so that's a great one to have. But chlorine, the other halogens are usually -1, but they can also be some other charge as well. So we got to be careful. But what rule we have going for us here is that hydrogen, when it's part of a compound that is a non-metal, it's always +1. Hydrogen can be -1, but it has to be attached to a metal. So this is a non-metal, so now we have it. So oxygen is -2, hydrogen is +1. Those two rules are going to be our best friends here. That hydrogen and oxygen are part of so many systems that we really have that going for us. Now, here's the exception. Hydrogen is attached to a metal. One of the things that should stop you is that you see hydrogen is on the end. That doesn't come up too much. Usually the hydrogen, when it's part of a molecular compound, is in front. Doesn't have to be, but that should make you stop at least for a moment. And then we see that this is a metal. So in that case, hydrogen is -1, and that means this cadmium is +2. So that's the exception, and we have it hydrogen. The oxidation number of hydrogen is -1 in binary compounds with a metal, such as calcium hydride. This is cadmium hydride. So I'm putting in a lot of instead of doing out a whole bunch of easy ones over and over and over, I'm giving you all the different possibilities. So it's going to seem like, well, these metal hydrides pop up all the time. Well, it might be on the exam, but most of the time hydrogen is +1 because it's attached to nonmetals. Okay, here's nothing but nonmetals. Oxygen, sulfur, and hydrogen, so hydrogen must be +1. Oxygen must be -2 because it's part of a compound, and then we don't know what sulfur is. Now, here's where if you do enough of these, you should be able to see this is -6 +1 and +2, so this sulfur should be +4. But if you don't see it, that's fine. You just have to do it out. It has to add to the charge on the system, or on the species. The species is neutral, so it's 0 that we're adding to. So we have 2 plus x minus 6, equals 0. So x minus 4 is equal to 0, x is equal to 4. So +4. So you might be able to see these pretty easily. When we get to some more of the tricky ones, you might have to stop for a moment, but the more you do, the better off you're going to be. Now, for the halogens, again, the oxidation number, each of the halogens has an oxidation of number of -1, except when the other element is another halogen. Well, this chlorine is part of a compound, but this is not another halogen, it's just iron, it's a metal, so this is -1, which means this is +3. The more obvious ones won't do out the full little algebra, the algebraic formula there that we have done for the others. This one I'm going to do out. I'm going to make a little equation out of. Sodium is always +1. That's a rule that we already knew. Oxygen is -2. Chromium is X. We don't know what it is. Now, a lot of times students will put down +2 here because there's 2 sodiums. Don't do that. You want to have the oxidation number for 1 sodium. The 2 there tells us everything else we need to know. If you put a +2 there, and I see that on the exam side, do they think that this is a group 2A element, or are they doubling up because of that subscript? Normally you don't do that. You put in the oxidation number for just one element, and the subscript takes care of the rest for something like this, where we want to determine what X is. Now there's 2 chromium, so it's going to be 2X plus 7. So this is 2 plus 2X minus 14 equals 0, because we won't add up to the neutral species. 2X minus 12 is equal to 0. X is equal to 6. So +6. Now, here's the exception for the oxygen. Oxygen, when it's a peroxide, and the structure of this thing looks like this. When an oxygen is bonded to an oxygen, and then they are each bonded to something else, the oxidation number is -1, and hydrogen is +1. Now you might think, well, how do we know that? It actually works out pretty well if you think about it. If you take oxygen to be -2, you don't even stop to think, oh, it's -2, then that means that hydrogen must be +2. Can hydrogen be +2? It only has 1 electron, so it can't be. This is impossible. So if you start from the other side, each hydrogen gives up its only electron. So it goes to +1. That's as far as it can go. So each oxygen, since there's 2 hydrogens and 2 oxygens, each oxygen gets 1 electron, so it's -1. That's why we have to stop. There's no further electrons that the oxygen can get. Now I put this next one in because it's a little tricky. So this is +1. Carbon that we don't have a rule for, and it can be more than 1 oxidation number. Hydrogen is +1 here. Oxygens are separated, but that's okay. And then we have -2. So we have 4 plus X minus, or +2 times -2. So 4 plus X minus 4 is equal to 0. So X is equal to 0. So carbon in this case, each of the carbons, has an oxidation number of 0. This strikes students sometimes as odd, but the thing is, we got to remember what the oxidation numbers are telling us. It's telling us how the electrons are being shifted around. If an oxidation number is negative, it means it's gained some electrons from somebody else. So some other element has to be positive in this system. Well, the thing is, when an oxidation number is 0, that just means carbon didn't participate. It didn't throw any electrons around. It didn't gather any. It didn't give any up. It just stayed neutral. So that can happen. So you should be aware of that. All right, we have this guy. So this is +1 minus 2x. And so we have +1 plus x +3 minus 2. And this is equal to -1. There's a negative there. So this is 1 plus x minus 6 is equal to -1. So x minus 5 is equal to -1. So x is equal to +4. So there's 4, and then what we do is we have 4 plus 1 minus 6. So that's 5 minus 6 is -1. So when you're done, you can always double check. Just add up your oxidation numbers to make sure that you get the proper charge. Then we have -2x, so x plus 4 minus 2 is equal to -3. X minus 8 is equal to -3, so that means x is +5. So we have +5 minus 8 and -3, so that is correct. And then we have +1 here. And then this would be -3 to add up to +1. And let's see, is that the deal? Yeah, okay.